Assalamu alaikum. Welcome to my channel Jahangir Science School. I am Jahangir Alam. I am a science teacher. Today I am going to solve IGCSE O-Level Physics Unit 1 Chapter 1 Movement and Position Chapter wise question paper, past question paper solution. Today this is the third video for this chapter. Question number 3. A steel ball is fired. A steel ball is fired from a launcher. This one is a launcher on a adjustable table height. A student investigates how the range of the steel ball varies with the height of the table. So a student investigation is how the horizontal range of the steel ball varies with height of the table. Question is describe a method for the student investigation. Your answer should include details of the variables in the investigation. We use variable in the investigation. Then how the investigation will be valid, a fair test, how the range will be measured accurately. So first we have to find out the independent variable. Investigation is how the range of the steel ball varies with the height of the table. So independent variable is height of the table. Independent variable. So height of the table is independent variable. So at least 5 different heights tested. Range is dependent variable. So height is independent variable. So height is independent variable here. Independent variable because in our investigation the range of the steel ball varies with the width. After width, in your question, remember in your question, the quantity which after width. So with the height of the variable. So we want to measure the range of the steel ball. So steel ball is range of the steel ball is dependent variable. Now at least 5 different heights tested. Range is the dependent variable here. Remember, range is dependent variable because we want to measure the range, horizontal range. Here a control variable for fair test. Remember control variable launching force, control variable. Say control variable for fair test we should fix this quantity. Launch speed or force. We should control. Launch force or angle of the launching, angle of launch angle of launch. So angle of launch should be same, or we should use same ball in the inter experiment. Same ball. We should use same ball in the inter experiment for fair test. Ruler is used to measure the height. So ruler is used to measure the height. Ruler is used to measure the height. To measure the height and range. So to measure the height and range, we can use ruler or measuring tape. And we can use record the video, record the video and playback in slow motion. Playback in slow motion. To see where the ball lands. Now question number B. Now question number B. The graph shows the student's result. Range in meter in the y-axis and table height in meter in x-axis. Because table height in meter is independent variable, range is dependent variable. Remember, when we plot a graph, we must plot independent variable in x-axis and dependent variable in y-axis. Draw the best fit line. Draw the best fit line. So this is the best fit line. Estimate what height the table would be when the range of the projectile is range of the projectile is 0.6, then calculate the height. Calculate the uh, 0.15 because here 1.15. 0.15 is the height. Justify why student has plotted a line graph rather than a bar chart. Because both variable variables are continuous. When both variables are continuous, then we can we can use line graph instead of histogram or bar graph. When independent or any dependent and independent variable are discrete number or quality, then we should use bar or histogram diagram. Now last question, question 4. Roman 4. The range of the projectile is related to the table height by this formula. Range equal to launch speed into root over table height divided by 5. So we have to justify this relation. So use the data from the graph. Show that the launch speed of the projectile is approximately 3. So range, when range 1.92, range is 1.92 when height 2 meter. So when height 2 meter, range is 1.92. From the graph, when height is 2, range is 1.9 or 1.92. So by using this above formula, 1.92 equal to launch speed v into root over 2 by 5. So launch speed v equal to 1.92 divided by root over 0.4. So launch speed equal to about 3 meter per second. So the launch speed of the projectile is approximately 3 meter per second.